Hello viewers, this lecture is based on the way of identify KC. This is second part of the lecture in which we first part we have discussed about the physical method. In this lecture we're going to discuss about the chemical method to identify the KC. So first of all, you can rectify this method by its name, the chemical method. So basically in this method you basically apply its formula, that is P upon R and concentration of both. So this is simple formula in which you simply put this formula and simply identify the Kc. Just suppose that for instance I do have a reaction in which we do have 1 mole, or the concentration of the reactant for the product side is 1 and the reactant side is 2. This is the concentration that is given. So basically we're going to write the concentration. Just suppose that this is A. It has concentration of 1, and we do have B. It do have concentration of 2. So what we're going to do is simply write its formula, or the unit, sorry, formula, mole units. That would be mole dm cube. For down, it would be equal mole dot dm cube. After that, whole square, because we do have 2 concentration here. So what we're going to do is simply cancel this one with this one. What we will left with 1 upon mole dm cube, right? When it will go up, what will be the result? As a result, it would be mole inverse dm cube. It will be also inversed, and this is our answer. If there is a condition in which you have to just tell its Kc, what you're gonna do is simply end up writing this, whether you can be asked its formula. So you can write its unit like this if it is in the question. Or the third way to identify the Kc is that if you are given, just suppose that I do have a example that in essential step, this is a question, an essential step in contact process is the oxidation of SO2 to SO3. Now you have to find out if in an experiment there are 5 moles of SO2. Let me write it here, 5 moles of SO2 and 4 moles of O2. Of course we are doing oxidation, so there is presence of the oxygen moles there, and 2.8 moles of SO3. 2.8 of SO3. Let me just remove these all so we can do it comfortably. Okay. At equilibrium state, the 2 dm cube flask, that was a condition that was given, that there is a flask that is of 2 dm cube and you have to calculate the Kc. Ding ding. Now what you have to simply do is to first write the reaction in which we do have 5 moles of SO2. So basically just take a look that how many the reactions are there. Just suppose that we do have a let me first write a condition. SO2 plus O2 that makes up, this is a reversible reaction, that makes up SO3. Now I have to simply balance it. There are 1s, there are 1s, there are 3 O. So basically here are 4 O. So we're gonna write 2 here. It will be 2 3s is 6, and here we do have 4. So if I write here 2, it will be 2 2s are 4, and 2 it will be 6. It is balanced. Or you can simply write, because I don't want to use 2 moles of SO, but the thing is that here there will be 2 moles of S, so I will write here air. Now it is fully balanced. Now simply you can see here a difference, that it is now 5, and where it was 1 in a simple reaction it is 4, and where it was 2 in a simple reaction it is 2.8. Now check out the difference first. If you can identify it by difference, that would be well and good. Now you can see here it is increased by 3 times. It is increased by 4 times, and it is increased by 0.8 times. Is there any relationship? I don't think so. So what we're going to do is simply start writing the concentrations. So here we do have a proper manner where we have this as a reactant, this is product. So we're going to write the concentration of SO2. That would be 5 upon 2. Respectively, it will be 2.5. I'm going to first write here 2.5. After that, we do have to write the concentration of our O. So basically, O's concentration is 4, of course. After that, I have to write the concentration of SO3. So it will be 2.8 upon 2. And that will be equal to 1.4. So basically now we are done with the concentrations. Let me highlight these concentration: 2.5, 4 and 1.4. What we're going to do is simply again using this formula, you have to simply put down these values into the formula. First we're going to write the product, that is 1.4, and its concentration is 2 because there are 2 moles in the reactant side. After that it would be 2.5, and its concentration would be this, and then sorry, it's not O, that would be the concentration, that is 4, and we will write it simply. Before starting anything, cancel these out. Like this 2 would be cancelled with cancel it by 1, like 1 this one and 1 this one. Okay, now what you are left with? You are left with a pound, and that would be 1 a pound, concentration of 2.5. Now simply what you have to do is to simply write its, and you will end up with a simple answer. And plus, let me tell you that the key point to identify is that it will be mole inverse, and it will be dm minus 3. No, it will be plus 3. Okay, plus 3. And we are done. So thank you for watching this video. I hope that you get how we can identify Kc.